Hello everyone, welcome to a new Substance Designer tutorial. We will be continuing with the FX map node. I will prepare a few examples for you, and before starting, we will go through all of them and see what they do. The first one is a height map that generates a few flowing lines that start from a grid and they follow the contour lines. Let me show you what it does. I'm going to go inside this node. We're going to generate a grid of points and then we're going to follow a normal map and then draw these lines flowing from high areas in our height map to low areas in our height map. Okay, so let me go in here and show you how everything starts. Okay, so we're generating a grid of starting points. And then if I plug this level nodes here, which shows us the height map, we're going to see that whenever we have point starting in the high regions or in the areas where the high map has bright values, then these starting points or these lines are going to flow towards regions of darker brightness. So in a way you can think of this like a stream of water flowing from high areas to low areas in a landscape. Okay, let me go inside and for a brief moment I will deactivate a rotation parameter that I added. So here into this quadrant node, I will briefly set this value to 0. Okay, now when we go back inside and use this iterate node, I mean this one, and increase this value, we can see how the line starts to point from the highest values in the height map towards the lowest areas in the height map. Okay, I think this effect is interesting. We have the options to change the grid density. We can change the position of the grid. So for example, I can double click here and one of these two pins control the position of the grid. I think it's the other one. So for example, we can change the grid. We can change its size, so shrink it or enlarge it. We can change the density. So for example, have X and Y amount. Currently it's set to 8. Maybe we can change it to a really large value if we want, maybe 256, and go in here as well, 256. Okay, and then we can enlarge everything, the entire grid to cover our space, maybe something like this. Okay, now this is obviously too dense. Maybe I can tweak a few things about it. Maybe I can go in here and I think I should change this parameter. This is going to change the size of our arrows. Okay, but it's still a very dense grid, so let me go back and instead put something maybe like 32 by 32. Okay, and then I should start and increase this number, so our line starts to flow from high regions to low regions. Okay, we also have a parameter that allows us to stop um, if the values in our height map are getting too low. We have a threshold value that will stop our lines from flowing. But yeah, in this example, we will create a grid, and from this grid, we will generate a few flowing lines that follow the landscape or the terrain that we have or the height map that we have and generate this kind of pattern. Let me hit a couple of undo, okay, to get back to what we wanted. So this is our current state. And if we go here and change the disorder parameter of the Perlin noise, everything adapts to it and moves accordingly. Okay, so go back inside one more time into the compute node here, and just for a brief moment we can play with this rotation. So initially this is set to 0 and we have a bunch of starting points and they go towards their low points in the FX map. We can also rotate these vectors, and then now our lines, you can see how they follow the contour lines of the height map. And I think this effect is interesting. We also have, based on this effect, we have another interesting one, which takes in an input image. It's a grayscale image. I don't want to show the image because I'm not entirely sure. These images don't belong to mine. They are 2D portraits, 2D black and white portraits that I downloaded from the internet. I don't want maybe YouTube to block the video or anything like that just because I used these images. It can be any grayscale image that you have, that's totally fine. But it's a similar idea. We use this black and white portrait to generate a normal map from it, and then we generate a few uh, randomly walking lines um, based on this vector field, and they're going to create this effect, which I think it's interesting. You can play with this intensity parameter so you can see how you're getting various effects based on that. So what really happens is I start with some lines, maybe go inside here and only reduce this to a single starting line, and then this line starts somewhere maybe here and then reads the normal map and then moves to the next place and jumps around based on the vectors from the normal map. Okay, so this is what it does. Okay, so it's just like a random walker, but it's informed by the vector field in our normal map. 256 it was before, and then if we start to add more lines, so this was the starting point, and then around this point I generate random lines in a circle with a certain radius, and then you can see that if I add another one, it's probably starting from here or from here. The radius, it's quite large, so I generate around this point, I generate randomly starting lines in a circle like this. And if you add more, you start to get more and more definition about your portrait. Okay, I want to hit undo a few more times. Okay, so I had here as well 256. And then if you play with the blur parameter, you're going to get different effects. For example, if the blur is more consistent, you would have more smoother lines that follow the contours of the portrait itself, but then you kind of lose information about the portrait itself because the normal map is very blurry. But if you make it like this, now you're starting to reveal the portrait. So you can get different effects based on this one. Also, you can see it's fairly fast, doesn't explode. It's nothing too crazy, even though it's doing around 60,000 uh, iterations. Uh, Feels pretty responsive. This one, it's a similar effect, but instead of randomly jumping around, I just create rings, concentric rings. I'll be showing you in a minute what I mean, but also you can play with this parameter here. So for example, if you increase the blur, then you're going to get kind of this concentric rings. Okay, so leave it somewhere like this, where I like to have it around 7.5. In a way, I think I still see some flowing lines here, but also I feel like I can see um, those concentric circles and also this radial pattern somehow forming here, which I think is interesting. Okay, and I want to go inside and show you what's going on. So I currently have 64 of these concentric rings. I can just decrease this value so you can see what's going on. So basically I create rings and then I have random lines following the portrait. And then if you increase this number, then you start to reveal more or less of the underlying pattern. Okay, great. And lastly, I have this example here, which I think it's very cool and powerful. And I think this one is the most important. And what's happening is that we're going to generate, like you can see, we generated the entire drawing here in the FX map node. We have a few stylized flowers, and we build a procedural system that has multiple parameters connected together. And most importantly, everything, absolutely everything here is driven by this um, Perlin noise map. And this Perlin noise drives, for example, um, the size or maybe the length of the flower itself. It drives the number of petals. It drives how many of these wiggly waves it has. Also drives the number of leaves. Also drives the length of those leaves. It drives the number of petals. It drives the size of the petals. So you can see every single flower here is in this 2D array. Every single flower is unique. So what it happened is that I generated one single flower, but then that single flower gets duplicated and re-evaluated every time when it's duplicated, but based on the input values from this Perlin noise. So what's happening? This Perlin noise is in a way functioning like an ecosystem map, where let's say this map actually says like, hey, this is soil that has maybe water and nutrients, and whenever we have bright values or bright regions, maybe the soil it's rich in water and nutrients, and whenever we have a dark region, maybe that patch in our area, or maybe this in this area, maybe the soil is like less nutritive and things like that, has less qualities. And then this informs our plants. So for example, maybe we can interpret it like, hey, Just I want to put a level nodes here, decrease its brightness like this, and then plug this thing in here. So you can see how our flowers that are in these regions are smaller, they have less petals, less leaves and things like that. But then other plants that are in regions where the soil is have more nutrients, they are well developed. And then if I change this pearly noise, so let me preview the ecosystem itself, then if we change the pearly noise, then everything adapts. So it's again, it's fast, but then it means like every single flower it's redrew or evaluated based on this pearly noise. Okay, so you can get really sophisticated with all of this and control very, very sophisticated systems with maybe hundreds of thousands of parameters linked together and have everything then controlled by an exterior information or like maybe an exterior map like this where high means, I mean, this can be an entire ecosystem and generate your plants based just on this map. Okay. Going inside, we have this um, area. This part generates the flower itself, and then this part generates a grid. And the flower itself, it's duplicated, but every time when we generate a new flower, that new flower reads the parameters from the pearly noise and then gets built based on the brightness of the pearly noise uh, at, let's say this is the origin of the plant or maybe the birthplace of the plant. The plant samples the pearly noise at this position, and based on the information or the brightness contained in the pearly noise here, then the plant itself is generated, and it's like shorter or taller or has many or fewer leaves, and then has well developed flowers or just some small flowers like this where they have maybe just 5 or 6 petals, and then in this area we have maybe 17 or 20 like so. Okay, so let us return to this first example. Okay, so I'm just going to duplicate this part just to have something to look at. I will be building everything again from scratch, but I also want to have a simple example that I can refer to sometimes because maybe I'll not remember every single step in those examples. So I'll be referring to these things. Okay, so make a new pearly noise. Okay, I want to reduce its size, something like this. I will be using a normal map. The size, the intensity of the normal map, maybe put it to what I used here, 16. I will also use a blur node and set it to maybe 1.5. The blur node actually smooths the normals a bit and makes those lines flow continuously. Otherwise, you might get some jiggling somewhere. Let me try and see if this still happens. So here, if I remove the blur, it seems to be smooth, but I had a few instances where those lines started to create some zigzaggy patterns. Maybe we will encounter that artifact again. Okay, but for now I'll be leaving it like how it was before, 1.25, and also have my blur here 1.25. 1.25. Okay, great. Now let's create the FX map node. Make it grayscale, plug our normal map inside. Okay, And then I want to create like a control point, maybe. Yeah, I want to create a pin that allows me to move the grid. I already have a few here created, but I will make another one, or maybe another a couple of those pin nodes. So I will just double click this grid here in our canvas area, and you can already see that I have two of those pins. These are from my previous examples here. I'll just create a new one. So parameters, I'll hit a plus and I will name this one pin 3. Okay, it needs to be the type needs to be float 2 because it's a position into this space, and I also want to make it a position. This is the actual pin itself that we can control. I will default this to 0 0.5 and 0 0.5. Okay, that should be it. So going inside, I will set this blending mode to maximum. I'll create a disk. The disk size will be 0 0.05 and 0 0.05. Actually, I will not use a disk. I will use instead an arrow because I also want to show you how to orient patterns. So basically we will be reading the vector fields here and we will rotate this arrow to align with the vector fields in the normal map itself. Okay, so I will be inputting our arrow there. So instead of a disk, go inside, bring this again back to 1, sorry about it, just use an input image, and the input image should be image input 1. I will also change this to nearest instead of bilinear. This is a personal preference. I'll show you why if I remember at the end. It's not a really big deal, but I want my patterns to be not at all filtered because I usually use a fxAA node at the very end after we generate the patterns in the fxmap node. So I'll be putting this to nearest. Okay. Then I will be creating an iterate node, and I want to do this. I just don't want to spend too much time on this, but maybe for some of you who have background programming, a programming background, you might be attempting to think about this like, hey, this is an object that we're creating and then we reuse this object multiple times with different inputs and things like that. So I like to think about it, but don't it's not like the absolute idea of object oriented programming. I think it's helpful to think about it in this way. So for this reason, I will name this like quote unquote object. Okay, and the object it's going to be actual, let's say that this is a maybe flow path. You can come up with your own name for this. Okay, go connect everything. So the quadrant node needs to be connected to the right input here. Set this one as a root, and in the iterations we need to define a few things for ourselves. So first of all, I want to create a constant length. Yeah, so I'll be I mean a constant length. I just want to use, I usually use all the time 1 pixel size. So in order to obtain this value, I need to get the size, and get size, it's the size of the node itself, which is like 2048 by 2048. These are the numbers that will be contained here in this variable, and I want to divide 1 by this size. So the result of this division, it's actually the size of 1 pixel, which is a really, really small number because it's like 1 divided by 2048. It's 0.00 something. I don't know. I will be setting this or storing this as a float. So this is a vector float too. I need to extract one of these components because my image is square. I can extract either one. That's totally fine for now. I want to set this, and I usually name this one px from 1 pixel. Great. We defined our first variable, which is called 1px. Then I want to define a few other things. So for example, I'll be defining a position where my line is going to start. And remember, we want to bring in the pin that we just created. So get float 2, and from this list, we should be able to find the previous pins, but I will be choosing the latest one, so pin 3, and I want to set this as origin 0. Okay, so this is going to be a position or a vector that we constantly update. We add to it the vectors from the normal map, and then this is going to uh, create the flowing paths for us because we're going to add step by step those vectors, and this is essentially going to create the path for us. And lastly, I want to mention or define how many times do we want this process to repeat. Basically, this is going to be controlling the length of our flowing paths. This and another parameter that is going to be the spacing between our arrows, but this is basically going to control the number of steps and the length of our path. So I will be using another sequence node. I will be using an integer. Maybe I want to repeat this process 64 times for now. I usually take this integer and convert it to a float and then set this float. Maybe, I mean, actually assigning a value to it, not a value, but assigning a name to this value. So I like to borrow from Houdini notation. So I'll use a numpt 0. Feel free to use whatever names make sense for you. You can, for example, use I or I++ or something like this. Okay, and lastly, I need to actually output this number here as an integer. So this is going to generate the dollar number variable for us, and the dollar number is going to be 0, 1, 2, 3, 4, 5, 6 up to 63 and minus 1. Okay, good. And now we need to set this one as an output. Now, even though we haven't seen it yet, this executed 64 times, which means we have 64 triangles on top of each other. I think maybe I should go here and reduce the size of our triangles. So here in pattern size maybe, or maybe not yet. Okay, let me think. How should I do this? I'm not going to do yet. I'm not going to deal with the pattern size yet. And the reason for this is because I want to show you that it's very helpful to work and do all your computation here in this luminosity channel, and then set uh, or assign variables to your computation, and then just call the variables into the relevant channels. So for example, if I wanted to change the pattern size, I will be already working with this channel separately from the luminosity, which I don't want to do yet. Okay, so I will leave it like so for now. I just want to do another thing. The branch offset needs to be set to a minus zero point 0.5 and minus zero point 0.5. And the reason for this is because the FX map node considers 0, 0 to be here in the center, and that's fine most of the times. But then when we actually want to work with images that we input into this one and want to sample information from these images, then the actual 0, 0 it's here. So we want to have like the correct space in both cases. So if 0, 0 in this space it's here, then I also want to be 0, 0 here as well. So for that, you just go into this branch offset. So you have branch offset and pattern offset. This one of this, maybe this one is like a global offset and the other one is like more like an individual one. So I'll be just putting minus 0 0.5 and minus 0 0.5. Okay, great. So everything offset it there. And now I want to go here. I mean, for now, maybe just do it like this. Okay, so our arrow now sits in the corner. Okay. Now I will go here inside the luminosity and empty function, and I will just get the variable that we have, our position 0. So I need to type it, pose 0. Make sure that you type this correctly as you define it. So just to double check, go where you define the variables here, for example. And then actually we named it origin 0 instead of pose 0. So I will be copy pasting this, copy, and then go here, and instead of pose 0 it's origin 0, so paste. Then I want to add something to this, and then I want to set this origin 0. So this procedure here, it's taking the original information, the original position, then adds something to it and then updates the original position, and then in the next iteration this information goes here and then the process repeats. So then to this origin, a new velocity vector coming from the normal map, it's going to be added. Then this is going to update our current position. This is going to be stored as the origin 0 again, and then in the next iteration this is going to be passed here, and then this is going to be updated every single time or every single iteration, and this is going to dot by dot create our continuous path, or like arrow by arrow it's going to create our continuous path. Okay, so this is like our position update. Then what I want to do, I want to realize that I am in the luminosity channel, and the luminosity channel wants just to have as the last information in a sequence of in the chain of sequence node. The last information that gets plugged into the sequence node needs to be the actual luminosity of the pattern, which can be a float or a color, so a float 1 or a float 4. We're going to be just grayscale images, so for that I just need to put a sequence node, and then I will be putting a value of 1, and then set this as an output. Great. So nothing yet changed, but now I can enlarge this thing a bit. So currently this origin is starting at 0.05. I mean 0.5 and 0.5 here in the middle. I want to sample my normal map. I also want this to set this filtering mode from nearest to bilinear. Just want to make sure that I'm sampling the correct image, which is image input 0, right? This is our normal map. Then our normal map needs to be to have its range change from 0, 1 to minus 1, 1. And from this, I just need to use the x and y vectors. I only need these components. So x and y is going to give us the vectors that point in different 2D directions here. I need to multiply this by 2. So if I want to multiply a vector by a number, I use scalar multiplication, float. This is going to take our range of vectors between 0 and 1 and is going to put it between 0 and 2. And now I just need to subtract 1 from it. So because this is still a vector, I need to subtract a vector from it. So float 2, 1, and 1, and then subtract. Okay, good. So now we have the information that we want. This is our position, this is our direction, because we want to tell our points or arrows how to move. So this is a direction. And then just plug this thing here. Okay. Still nothing happened yet. The last thing that we need to do, remember we computed our variable, we computed our origin 0. We just need to take that information and put it in the channel that actually wants to see that information, which is pattern offset. So empty function, and I just get float 2 and origin 0. Okay, and if I have this as an output, now we should see things going on. So okay, currently we have something going on, which I think is good. Let us try and make sense of what's going on. I will be using a levels node here and here, and then maybe just decrease this decrease the brightness. Okay, so let's try and understand where we start and what's happening. So 64 iteration, maybe if we decrease them, it seems like we're starting here, right? And then in the next iteration, we do this really big jump onto here, and then in the next iteration, we jump another big step here and things like that. Okay, so it's not bad, but what we really want is that we want those arrows to be equally spaced, right? So we want to create a continuous path, and these arrows should be touching each other tip to tail or something like that. So at this point in time, we need to use our size channel, and also we want to choose how long the arrows are and what the distance between the arrows is. Okay. So what's really going on here is that the normal map has vectors that do two things for us. One thing is the normal map provides us with vectors that act as a direction, but also these vectors have a magnitude, which tells us how long or how strong the push from that current vector is. And those vectors have different lengths, and in this case we don't want the vectors to have different lengths. We want all the vectors to have equal length, and we're going to only use the normal map just for direction and not for the magnitude of the vectors. So how to do this? Well, we have our normal vectors here from the normal map. This is direction, and we need to normalize it first. So we have a normalized vec2, What happened in this case is that the normalized vector made all the vectors from the normal map um, have a length of 1. But then here at this point in time, we can take this length of 1 and resize it how we want. And this is also where our 1 pixel is going to come in. If you remember, we created the variable 1pix, 1px. This is just 1 pixel. I want to multiply this maybe by float by 16. So now I want the distance, or I want the distance between my vectors from the normal map to be 16 pixels. Now this is 1, and I just need to multiply this by this, okay? So this is a vector, this is a float. I need to scalar multiply this. Okay, so now it seems that we're having equal distances between vectors. Now I need to also um, change the scale itself of the arrow. So the distance is constant, but I also need to resize the arrows themselves. Okay, so sure enough, we can do this. What is the size that we have? Well, it's this 1 pixel multiplied by 16. So the current distance between the vectors is 16 pixels. I also want the size of the arrow to be 16 pixels. So I can set this value here, 16 pixels, set, and name it arrow size. Okay, make sure that I copy this variable and plug this new variable into the chain of sequence nodes. Great. Okay, so go into the relevant channel where we have our arrows here, and then I hope it's not going to crash. Let me show you what happens if I just go here directly into pattern size. If I click this button here and I want to use an empty function, then all my arrows got resized uh, to 1. Okay, but I have a get float. I have this arrow size and I need to make it into a vector float too. Set this one as an output. So great, right now our arrows and the distance between the arrows is the same. I can change it if I want. So for example, I can go in here into pattern size, sorry, here, and maybe I can do, instead of 16, maybe I can do 32. Okay, so you can see now everything is correctly chained together. There is one thing that we want to do still, which is we want to orient those arrows correctly. Yeah, they currently form a path, but they are not aligned properly. So I want to each arrow to point with its tip to the next arrow itself. So we need to do this, and it's also a really simple thing to do. We already have this information from here. Remember, we're treating this as a direction. So we want to extract an angle from this. And for this, we have the A-tan2 node. Okay, so A-tan2, arctangent 2. This is going to take our vector as an input and is going to return an angle value, but this is from minus pi to pi, and we want to make it from minus pi to pi. We want to make it to 0, 1. Okay, so first of all, we divide by pi, and then we change the range. Now this is minus 1 to 1. We change this to 0, 1. So minus 1, 1 to 0, 1, and then we set this as rotation. Okay, then sequence node, and then rotation, it's plugged in. Chain the nodes together correctly, and then go into the relevant channel here into pattern rotation. get float rotation. Okay, so now our arrows are correctly oriented, and then let's test if things work properly. Let me double click, make a preview. We have this. So it seems like it functions as we're expecting. If we're starting anywhere from like a high area, then the arrows are going to point to a lower area. Maybe let's increase the iterations. Currently we have only 5. Then if we increase them, then we get our path. Okay, so now what happens is maybe we have like too many iterations here. So you can imagine that some lines are going to be longer, some of them are going to be shorter. Maybe if our line starts somewhere closer, you can see how in this area they just don't know, or they have nowhere else to go, and then start to pile up. And I don't want this effect to happen. So in order to, there are different ways to solve this. I will just be using like um like a thresholding effect on the luminosity channel. So for example, I'll be saying like, hey, if the value from the height map itself where the arrow sits is lower than a value, then just make the luminosity of the arrow, make it 0. Otherwise, leave it to 1. Okay, so let us do this. Go here into the luminosity channel. We currently output everything as 1. So all our arrows are controlled by this. But we can do something else. So remember, we have this is our position. We want to sample our Perlin noise, and our Perlin noise, it's not plugged it in yet, so it should be as a grayscale map as well, so we can sample from it. Okay, so now we say like, hey, at the position of the arrow, look into the height map itself, which is on channel image input 2, and then if uh, this is lower than a certain value, then make the arrow completely invisible, otherwise leave it white. So lower than maybe 0.2, something like that. Then if this condition is true, then the luminosity of our arrow should be 0, which means that it's going to disappear. Otherwise, the luminosity of our arrow should be 1. Okay, and then put this in here, and nothing happened yet. Maybe if I increase this value, you can see how we start to get rid of unnecessary arrows that we have. Now we can see this transition is pretty abrupt, maybe to 3.5, something like this. Just wanted to say that you can have a bit more sophisticated ways to do it. I think at this point in time, I just want to leave it simple like this. So you could have more interesting or more robust way to solve it. Like really what happens, the the solve for this would be to say like, hey, if my arrow stays in the same position too much, then it means that it's not progressive, so don't draw it. Like for example, you can see that this is the current position, and then the in the next iteration the position updated here. But then when we arrived here, all the arrows were sitting in the same place, just having different orientations. So it would be good to say like, hey, if we don't really move too much, then it means that we're not progressing anymore. We converge to the minimal point in our landscape, so we don't update. And this is going to change. We're going to have multiple lines, so that condition is going to change for individual streams or lines. So what we're doing here, in a way, it's kind of the same, not exactly, but it's like a simple thing. So maybe 6, 7, 4. Just want to make it a bit longer. 3. Yeah, I'm guessing values right now. 3, 5. Okay, no more of this. Good. So we have our object, right? So we have a thing that functions in a certain way. We have a line that no matter where it starts, it's going to end um, in a lower point, right? Okay. So now what we want to do is we want more of these lines. We already created one. We want to um, have more lines, and each line is going to do its own thing depending on where it starts in this Perlin noise, or in this landscape. Okay, so let us do this. So for this, we're going to make another frame and name this frame grid. Okay, and we're going in this grid to put 2 iterate nodes, and I only want them to be connected like so. And again, I will be using a different notation or naming convention here. I think uh, maybe for the sake of trying to have something in common with normal programming, I will be using I and J. This is an inner loop, this is an outer loop, this entire thing is a nested loop. So what we're going to create a grid, and the first loop is going to create a row, so it's going to create starting points in a row here, 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 how many times we want, and then the outer loop is going to just repeat this row. So we have like 1 row, 2 rows, 3 rows, and n rows depending on how many things we want. And I like to call this I and J. This is also something that you will encounter in math when you want to, well, you'll be using sums. You're going to have those things with I and J as indices. Also, you're going to have like neighboring pixels with the same notation, I and J. So I think it would be good to use I and J for notation. Okay, so first of all, I set this one as an output. I'm going to go here into the first one, go inside and make an integer. Let's say we're going to create an 8 by 8 grid for now. Integer 8. Then set this to a variable. I mean, what I usually do is convert it to a float, set it to a variable, which I will be calling I, and then sequence and output this here. Okay. And then I will be copying the same thing and put it above. But instead of I will be calling this J. Set this as an output. Now I need to do something. So whenever those iterate nodes produce the dollar number variable, but we want to be able to access it from every of these nodes. Now this produces the dollar number variable. This is also producing the dollar number variable. Well, we can't have the same name for those things together. One of those variable is going to be overwritten by the other. So then it means that I need to take this one, because if I want to access this information later in my, or lower in my graph, I need to access it. So for example, this can be dollar number only here below it. Then if I call dollar number here, then dollar number is going to be read from this. not from this. Okay, so then here I need to take dollar number and name it J++. And this is the thing that goes from goes 0, 1, 2 until 7. Chain everything together. And then go in here as well and get the dollar number. And this is going to be I++. So we have I++, J, and J++. And with those variables, we're going to make our grid. So currently we have our initial position driven by this pin here, okay? And we want to make our grid around this pinpoint. So our grid is going to be centered here. Okay, so let us do this. So we need to add something to it. We need to add the vector float too. But this vector float is going to be made of variables instead of constants, right? So we need to take our I and J and plug those things in. So get float, first of all, I, because I it's going to make our first row. I so I plus plus is 0, 1, 2, 3, 4, whatever until n minus 1. And we need to divide this to normalize this thing. So we want things to be between 0 and 1 because our space is between 0 and 1. So this is going to create like a row of vectors here and here and here and here and here equally spaced. If I just plug this thing here, then because this is like 0, 0, it's here, and then 1, 1, it's here, and then 2, it's here, 3, it's here, and so on. So that's why I need to make this division to put everything into the 0, 1 range. So plug this thing here. We already started to have things going on. Let me just do this into these iterations here. Leave this to 1, so we can at this point in time I want us just to see the grid happening. Okay, so currently our grid is not set to have its middle in this area. Currently the grid actually starts here in the corner, but that's fine. We're going to fix this. Okay, so we made the row and now we want to make the columns. So we get J++ and J. Okay, so now we have the grid that we can move around. Let me deactivate the tiling for a bit. Absolute no tiling. Okay, so now you can see that we're moving our grid and we have it, our pin sitting in the corner. Let me fix this. Go here, I mean here, and we want to, I think here we want to subtract something. We want to subtract 0 0.5 and 0 0.5. Subtract load 2, 0.5 and 0.5. Okay. Now our grid is sitting in the middle, and I also want to be able to scale the grid. Okay, so where should I do this? Here as well. So we can scale this scalar multiplication. Okay, just want to make sure. Yeah, this is now everything is here scaled down into a single point. the entire grid, but now if I increase this, we have our grid here. Okay, perfect. So now we have it. I just want to increase this size, and then I also want to go here into this one and also make the lines flow. So they currently only have one iteration, but now if I increase this, they start to flow. Okay, maybe 32. Great. So what else can we do? In our previous examples, we also added a rotation, which created some interesting effects for us. So we can take the grid itself and move it around. We can increase its scale if we want. And lastly, let me go here and add a rotation to it. So here into this one where we do computation, here where we have our direction, we want to also add rotation. So after this one, just add rotate vector 2, and then only you need to add an angle. So now if you change this, all the vectors are going to rotate and become like swirly. Okay. And lastly, I want to just, remember you can change the density of the grid. You can change um, the size of the grid. You can also go here and change the size and the spacing between the arrows. So go here and say like maybe 32. You have arrows like this. And I want to, before moving from this example, I want to say like, hey, the last thing that I want to do is either generate um, a random luminosity for each stream, or I can use the um, the Perlin noise itself to color the entire stream with the color that the stream is starting from. For example, the stream it's starting here, it's going to sample this thing here, and then it's going to color the entire path with the value from here itself. So how to do this? Well, we need to go into luminosity, and our luminosity is already here, and then we want to uh, multiply our next luminosity by this. So first of all, let's do the randomness. I need to, well, this node gets executed this many times, which is the size of our grid. And in this node, I want to create a random variable. So float one random, set it to, I will be just putting like random 0. And then add it to the mix, and then calling it. So again here, I want to get float random 0. And if I plug this thing here, we're getting everything. Let me just get this out of the way for now. And yeah, it seems to be doing it correctly. And the reason that I wanted to say that we want to multiply with what we already have, it's because that this part here got helped us get rid um, of the arrows that were piling up, but now because we changed the angle, they are no longer piling up. Let me return this to 0. So yeah, I'm talking about these areas where arrows are piling up, which I don't like. Maybe for example here. So this helps us get rid of those, and this gives us the randomness. And then if we just multiply those things together, we're going to get the best of from both. So random and getting rid of those converging arrows. Maybe still, if we feel like, hey, here is too much, we can just play with this value, increase it, and it's going to make things disappear. I would leave it like this for now. Or return the rotation maybe back to 0.25. Okay, and then I want to use the Perlin noise to color the streams based on the air starting value. Okay, so how to do this? Well, instead of using the instead of using the random 0, we need to do the following. So I mean, I think we already have this information here, and maybe we can plug this here, right? Well, it seems like it's doing its thing, but actually, if you would look closely, you wouldn't have like constant values. Here, it seems like, I mean, it doesn't seem, but actually, it's for each arrow, it's sampling the Perlin noise and change the value for each arrow. But what I really wanted was um, to have the entire stream with the same grayscale value that was from the Perlin noise at the starting point, not a different value for each arrow. So how to do this? And also let me show you what's going on, because I think it's difficult to see, but maybe I can just put a gradient map after this, and then just use some color, some red, and then maybe here some um, blue, and then maybe some other colors in between. Okay, and I think let's focus on this path. I think we should be able to see if I start to crank or maybe bring those values close together. I think we should be able to see multiple values happening. Yeah, so this is what I'm talking about. So you can see like this path itself has multiple values. That's why I'm getting like green and also this pink and things like that. So I didn't want this to happen. I want to have like each stream to have just a constant uh, value, not a gradient along its side. Well, I need to create a variable that only samples the Perlin noise only at the beginning and use that. So well, I think we can do this. And the problem is that we use the variable that we're constantly updating. So go back to luminosity. Well, I use origin 0, right? And origin 0 gets updated all the time for each of this. But then when we computed this, or when did we created this variable? Well, we created it here. It's pin 3 plus all this greedy part, all this grid part, and then we set it as origin, and then we currently update origin all the time. But if I only want the values at the beginning when we created the grid, I just need to create a new variable from it. So maybe set and I will say like initial origin or any pose maybe. Okay, any pose. So initial position, bring this to the sequence and then chain it. So now go back here into luminosity, and instead of using the origin, we'll be using any pose. Okay, so now you can see that our thing is constant. Okay, well, perfect. So we have it like this. I will be sharing the Substance Designer file. I want to move to the next example, but in our previous example here, I made these graphics, which um, I think I like how it went, and I just want to show you that I use the diffusion color node, and I really love this node. It gets or creates some really interesting glowing effects. So you can have a look at how I use this node to create this effect. So the diffusion node, it's like a blur node, but it's a bit more advanced. What really happens is that um, I mean, I can show you. Let's make a shape like this, and then you blur it. Something like this, and then you add the shape back. Okay, so kind of this is what it does, but multiple times. So it's taking now the blurred version and adds on top to it, and it's doing this multiple times. So kind of this is what the diffusion node doing, but it's doing it in a really fast and clever way. So definitely not like this, but it's different than the regular blur. Okay, and it's actually blending between it can be blend between like different colors and different values and things like that. It's a really cool and interesting node. So it gives super amazing and beautiful results. So I like to use it all the time. Okay, moving on to the next example. Okay, well, I'll be duplicating this part here. Where I have my image. Again, I don't want to have any kind of problems with YouTube. That's why I'm not zooming too much on it. It's not any kind of crazy image. It's just that I don't own the image and download it from the internet, and I don't really want to use it. So I'll be putting a uniform color on top of it. Okay. And then avoid clicking it. Okay, so maybe for now, just take this out of the way, or maybe zoom really far. Okay, and then make an FX map node. I want to plug the image itself in there in the image input one, then also use the normal map, double click it, make it grayscale. Okay, get back here, zoom in. So now we can see the image. Go inside. I will change this for now to a disk, make it maximum. The pattern size we're going to change later, but for now make it like 0.05 and 0.05. Okay, move this branch offset to minus 0.5 and minus 0.5. Okay, good. Then use an iterate node. I need to also create another pin. So parameters pin 4. It needs to be a float 2. It needs to be a position, also needs to be defaulted in the center. Good. Now we'll be going in here, empty function, get our pin 4, set it to pos 0, maybe. I can use different names for my initial variables. Also want to get float to do my 1 pixel size. Do I use this here? Not sure. Maybe for now don't create the 1 pixel variable, as I don't think I'll use it. Sequence. Specify how many times do we want to repeat. This is something maybe like 4,000 times or 96. To float, set numpty 0, and lastly do this and this. Set this as a root. Go here into luminosity, get the position 0, add something to it, set it sequence output the luminosity. For now we're going to do everything by one, but then we're going to actually sample from the image itself. Set this as an output, go in here into pattern offset, empty function, get float to position 0. Set this as an output. Now our dot moved in the middle, and if I double click here, go into preview, now we can move the dot itself with this pin. I know all these pins are kind of distracting, but maybe it's not too bad. Okay, so now go inside here and want to update the position. So we get in our normal map sample. Just want to make sure that our normal map it's image input 1. So sample image input 1. Also, I set it to bilinear. I only need X and Y from it. I need to not to normalize it, but I need to change its range to -1, 1. So for this, multiply by 2, float, and it needs to be a 2, and then subtract 1 from it. One needs to be a vector, 1 and 1. And I also multiply something here. That's like not absolutely necessary to do, but I'll just use a scalar multiplication. And then for this, I need to create a new variable here at the top. So here I can just put a float, maybe make it 0.75 and set it like magnitude as a variable. So set magnitude sequence, chain this into the mix, and then here we need to get it. So get float mag. So this is going to multiply our vectors. So it's doing something. It's already cool. It's creating these point clouds. You can kind of already see this is maybe like an eye, and this is like the nose, and this is like the mouth. So definitely already looking good, but what I want to do instead is, instead of using points, I want to connect these points with lines. So we need to adjust a few things. So here into this luminosity, I want to, in order to do lines, there are multiple ways to do it. But a simple one is, instead of using circles, I can use a square, and I can use a square like, for example, let me just go here and play with those things and show you. Maybe if I decrease these things a bit, maybe when I rise somewhere, like in the beginning. Yeah, between this point and this point. So you can see these 2 points, I have them. So instead of drawing like a line from here to here, what I can do is I can just place a rectangle that has its length as the distance between these, and it's placed here in the middle. So instead of drawing a line, I can just put a rectangle between these 2 points. I just need to compute the average of those 2 points, put the rectangle in the middle, and then also compute this distance just to make sure that I can elongate the rectangle with the distance between these two. And then this is also going to happen to this point as well. It's going to put a rectangle here in the middle of them, and then also it's going to compute the distance between this and this, and then it's going to scale the rectangle to match this distance. Okay, so let's do this. Change the disk from disk to square. Now we have squares. Go back into luminosity. How do we get this average? Well, remember, this is our initial position, and this is after we update it. So initial and update. Well, we want the average of this. So we have a average float too. If you don't want to use this average node, you can just add them together and divide by 2. Initial position, updated one, take the average, and um, just name this in a different way, because I don't want things to mess up. So I still want to have my computation happening, like my position to be updated. But now I can just go in here and say like, hey, set this to maybe average, or I'm going to just say midpoint. Okay. And then add this to the mix. I mean, put it in the sequence. So I have position, and then I want midpoint, and then chain also this. So I have all things together, all my variables, position, midpoint. Okay. So then what will happen is, instead of using position, we're going to use midpoint. And looking at these 2 points, I'm expecting that when I will be using this midpoint, I'm going to get a point here between these two. And between these two, I might be getting a point here. So let me do this. So here in offset, instead of pose 0, we should use midpoint. And if I hit enter, yeah, indeed, this one moved in between. So, okay, first step out of the way, we did it. Now we need to compute the length. So going back here, well, how should I do this? I think I should do like a subtraction. So again, the previous position, the update position, I just need to take the difference between them. Okay. So what's really going on here? How are vectors actually? Like a current vector in Substance Designer, those 2 points, you see them here, those 2 points. But really what's happening is that in Substance Designer, those 2 points are an arrow from the origin to this point here, and another arrow from this origin to this point here. And you only see those patterns placed at the tips of those vectors. If you subtract these two vectors, what you're actually getting, you're going to get a vector that points either from this to this or from this to this, depending on the order of the subtraction. And now, if I have this vector here, if I just take this length, it's giving me exactly the distance between these two things. Okay, so that's happening. So then length, and then set this as len, short for length. Add this to the mix. Okay, now we have it computed, but want to go in here into pattern size. So don't want my computer to explode. I will be deleting for now. This one, go inside, get float, len, and then vector float 2. So this is going to be the length, and this is going to be the width of the pattern. So we computed the length and the width, something that we can decide, something like this. And then just output this one, set as an output, and plug this thing back in. Okay, so we got a bunch of lines. And the very last thing that we need to do is compute their orientation such that they will be connected and make like a line that's fragmented but continuous. So all those segments are going to be linked together. Okay, so we need to do this. Go back here into luminosity. We computed midpoint. We computed the length. We also need to compute the rotation. Well, from this subtraction here, we need to take the arctangent. This is going to give our angle. So a tan 2, this thing here, and this is from minus pi to pi. We want to bring it to 0, 1. So divide by pi, and then 0, 1, minus 1, 1 to 0, 1, and lastly set it to rotation. ROT, short, sequence, this, this. Now we have it. Great. So we need to go here into pattern rotation, get float, not float 2, but get float, ROT, set. Okay, so now we have like a continuous, like a linked line of segments. Good. Now let's increase this number of segments and see what's happening. Okay, so we created like our random bugger, and maybe I can put this to 256 for now. It's giving me this. I also want to color those segments based on the value of our image at their midpoints. So if you remember, each segment has it's placed here in the middle of segments itself, and then at this position we can look into our input image, which is a portrait, and then color this entire segment by that value from the image itself at this point. So for that, it's pretty simple to do. We already have the position. We sample. We need to make sure that we sample image input 0. So image input 0, it's right, and plug this thing here. And now we get it like this. Okay, So good. For now, we're seeing this line. We might need to add a rotation here. So rotate. From practice, I noticed that this works interesting, but we can also play with this. But for now, we're just going to rotate, and 90 degrees rotation is 0.25, something like this. Okay, good. So we have one line. Now we want to add more lines. For now, I will be just decreasing this to only one, and then maybe two, just for visibility, something like this. And then we will iterate again, go in here. How did I name this? I named this numpty0. I'll be just copying this, empty function paste. I will be naming this ptnum -1. So whenever I have, this is my convention, feel free to adjust it. But whenever I started with this node, and whatever I put, if I put like iterate nodes below this, I name them like this is 0, 1, 2, 3, whatever it's above this, I name them -1, -2, -3. Okay. This is just a personal preference, not a big deal. So numpty -1, and I want this to be for now maybe 32. Probably increase this to more iterations. Set this as an output. Okay. Set this as an output as well, like as a root. And then in here, when we created our position, we want to add something to this. So this is like the middle of our thing. We can add to it. We can do a Cartesian node. And we want to add like we want to add starting points in a circle around this. Okay, so for this I need to take my numpty1, numpty -1, sorry. I also need to get my dollar number. I will be doing my t-1 parameter, which I like to do. So dollar number set ptnum -1 sequence get float ptnum -1 should be divided by numpty -1. And by the way, numpty means number of points, or at least in my head it does. So that's what it stands for. So numpty number of points, and ptnum it's point number. So the current number assigned to each point. Okay, and then I will name this set t-1. This is just the normalized range. So this is going from 0 to 31. This one is going from 0 to 31. This division makes everything between 0 and 1. Plug this thing here. Add everything to the mix. So this, and this. So we have everything connected. Okay, so then I will be putting a float here, just a radius, maybe 0.1. And then also I need to put like an angle. So for this I need get float t-1 multiply by 2 pi, just to make a circle. I mean 2 pi, it's already its own variable. So okay, so now you can see we're doing a circle around our pinpoint. Okay, great. And maybe I can just add more of this. So currently we have 32, but maybe I can put like 256, something like this. Okay. So now if I start to increase this number again, so this I have like 256 starting points around the circle, and now I need each line to go on its path and explore and reveal the portrait. Okay, so just increase this. Okay, so now you can see how it's revealing the image and the portrait itself. So maybe 256. Okay. So I think this effect is really interesting. Definitely you can take this point and move it around. Also, you can play with the blur node and change its intensity. So now we're getting like line following the contour and things like that. Also, maybe play with the rotation. So curious to see what happens if I go here into luminosity. Remember that we added this rotation here. If we change it, you get something like this. If you add it back, it's more like this. I think I noticed that it works good if you rotate 90 degrees the normal map vectors. So this is 0.25. I think this is revealing the portrait. Okay. Good. So we made a second example as well. And also let's make this one, because I also think it's interesting. So for that, it's almost the same as this one. I just duplicate this. So have it like this, and then I was thinking if I showed you, not sure if I put a magnitude here. I think I put mag here. I was thinking if I totally forgot about the magnitude parameter. Yeah. So I'm currently seeing this one. And then if I go inside and play with this magnitude, it's going to change the length of the segments. So I think this also might be interesting. So what really happens is that the segments between the lines are getting multiplied by this value. Larger value means like longer segments and things like that. I'll leave it back to 0 0.5, 0 0.75. Okay. And then get back to this one. What I need to do here instead to have the other effect is go here, bring this back to 1 or 2, maybe 2. So we have rings like this, maybe 1. Yeah, maybe 1. Also go here into the magnitude, and I think I decreased it, something like that. Okay, change its position. Okay, so currently we're affecting both with this pin. That's fine. And then I need to add another one here, another iterate node. I can copy from this one, copy, go inside of this one. Sorry, not this one, I mean this one. And then numpty minus 2 in this case. I will be doing maybe 32 for now. Set this as an output. Okay, great. Set this as a root. Okay, great as well. Go in here, get the dollar number, make our t minus 2 parameter here. So number set ptnum minus 2 sequence. Now we need to do our division, get float ptnum minus 2 divided by num pt minus 2 is the t minus 2 parameter. division, set t minus 2 sequence, and another sequence node is needed. So this goes here, this goes here, and this goes here. Okay, great. Now we should go in this one because this where we have our, is this here where we have our radius? No, I'm sorry, here we need to go. So this is where we have our radius, where currently our radius is a constant, so we can do it like this, but instead of doing this, we can just like use our get float t minus 2 parameter, something like this, and it generates the rings for us, okay, which I like this effect. And if you want more or less, just go here and play with this thing. So less, more, something like that. Okay, maybe go here, luminosity, maybe change the rotation. If it does anything interesting, it seems to be rotating everything all together. I don't know, maybe you can go in here as well, increase this number of iterations. It seems to just do a very similar thing to what it was before. I'll be leaving this to 1 just to get the rings. Also, at this point, you can play with this blur intensity. So something like this. I think it's also interesting. You can see like how the nose it's indicated by these lines and stuff like that. Also, maybe just blur it less, like total noise. I think that's okay for now with this one. Great. Now we should move on to the last and the most interesting but also difficult example, which was this one. Okay, so we created our fields of flowers, and then we input a Perlin noise to drive all the parameters together. So the parameters are linked together and they're driven by the values coming from the Perlin noise. And then if we change things, then everything also changes with that. Good. So I hope I remember how I've done this. If not, I'll be looking into the node itself, which has a few things moving on already. Okay, let me start directly. FX map, go inside grayscale. So currently, I mean, firstly, we're going to make the flower itself. We're going to use a disk. We will be doing this disk smaller. Okay, move everything so we don't forget about it. Move everything into the branch of set by -5 and by -0.5, sorry, -0.5 and -0.5. Then create an iterate node, and in this iterate node we will have we will declare a few things for ourselves. So first of all, float to will be making an origin. So set, I'll be naming this origin 000. Okay, I also need to make my 1 pixel size. So get float to size float to 1 and 1 division get one component, dx set, I mean sequence, it's fine, but I want it set, and then one x, right? Change these things together. Good. Sequence again, integer 512 for now. To float, set, this is numpty0. Okay, and then sequence, then this and this. Okay, great. We have it for now. Set this one as root. Go here into luminosity channel, into function get float. I'm getting the origin 0, 0, 0. I want add something to it. I set it back again. This is our update. Then I use a sequence node. Then I put a float for luminosity 1. I mean a 1 for the luminosity for now. Set this one as an output. And then move it here into pattern offset empty function get float to origin 0, 0, 0, something like this. I might be changing the name later. I think it's a bit too long. Again, not a big deal. Maybe move this to 0.5 and 0.5. Okay, so it's working. Now we can change the origin to be in the middle, but we also want to update it. So in order to update it, we need to add something here. So Cartesian again. And then for the magnitude or for the length of the vector, we need the 1px. So 1x. And then we're going to get this line. And also we want to orient this line upwards. So we multiply by 2 pi because this is what this node likes. It's in radians, so 2 pi. And 2 pi, it's 360 degrees. And then if you multiply 2 pi by something smaller than it, like for example 0.25, it's like a 90-degree rotation, but it went down and I want it to point up, so minus. Okay, so it's pointing up. Oh, great. Now we have this part, and I want to make like how we had here. Our lines were a bit wiggly, and they were like a sine wave, making them left, right, and things like that. So we want to do the same. And then I want to get in here, get my T0 parameter, which I always want to do. So number set to ptnum0, and then sequence, and then get float ptnum0 divided by numpty0. So this division, it's going to give us our set T0 parameter. Okay, great. Now we have this as well. Chain things together. So this, and this. So we can use our T0 parameter. So what is actually T0? Well, I can show you. T0 get float, and maybe in this case I will be trying to use the luminosity channel a bit more to for debugging purposes or for visualization. So if I plug this T0 here, you can see like it starts from 0 and ends up in 1 along the length of our line itself. So for now, I'll be leaving it like so, but I want to make this line go like in a sinusoidal way. So where do we change directions? Where we change directions here, but this is our main direction, so I kind of want to keep it, but also add something to it. So I'll be adding, and I want to add like this wavy behavior, which is coming from a sine wave. So I'll be getting my t0, and then I'll be multiplying it by pi or 2 pi, maybe 2 pi. And this is because trigonometric functions are multiple of pi or multiple of 2 pi. So if I do it like this and say like, hey, I only want 4 wiggles, and then do this, and then do this like sine, and then plug this in here. Now everything went like really, really small, but I can multiply this by a small value to decrease the amount of this effect or the strength of this effect. So float, and maybe like this. So plug this thing here and then just increase. Okay, so you can see I have like 1, 2, 3, 4 waves. So this is I multiply by 2 pi. If I just do 4 like this, I get something that I kind of don't really understand. But now if I multiply by 2 pi, whatever I put in here, I'm pretty sure that I get the number of waves that I want. So good, we have our waves like this. Now we need to move and make the leaves. So that's the original shape. We have maybe we're just disconnect this for a moment. So this is our initial shape, and then we want to add leaves. So let's do the leaves now. Go here, and we need to do a branch. So for this, we need the switch node. And also at this point, I will encourage you, if you haven't seen the previous 2 videos, you should also watch them when I use the switch node and things like that, because the only way to really get used to this is just by repeating it multiple times and seeing. It's kind of a back and forth, and I make things, the graph doesn't grow linearly, so I add things up and down and in the middle and move information and move parts of the graph from one node to another and things like that. So it seems to be a messy process, and the only way really to understand what's going on is just to repeat it multiple times. It took me, I mean, because I was guessing it and I was like not sure how to properly make this workflow, and it can be improved, but it really took me about like maybe 10 or 15 different examples or attempts until I came up with an workflow that made sense for me. And after a while, I feel more comfortable. Like in the end, I made around 60 of these really intricate graphs where I had like multiple iterate nodes and branch nodes and quadrant nodes, like really, really hairy graphs with a lot of parameters linked together and stuff like this. So definitely encourage you to watch this and do those examples multiple times, and also try to do it on your own and come up with your own way of doing things, because definitely this has a lot of room for improvement. Okay, but let's do the branches. So I need to take the information that I computed here in the luminosity, copy it, and then put it here. The reason for this is because we want to use this information to be able to use the information that we computed here. We need to move it up. So we have the information and the variables and all the computation available to this branch, but also to this branch as well. If we kept it here, everything and all the computation would be available further down the road if we use it. But now if we move it up, we can use it either on this way or either on those on this branch as well. So this is the reason. Okay, so now for the luminosity, we had T0, which is already computed. I can delete this part and then use for now, a dummy Boolean. If it could be a Boolean, it would be great. So get Boolean. Should be false for now, that's totally okay. I mean just Boolean, not get. Yeah, this one, sorry about that. Okay, and the reason for using this one, this node, this switch node expects a true false statement. So that's why it's here. Expected output type is Boolean. So that's why the last thing that we want to output to this, it's going to be a true false statement. And whatever it false goes to this path, and whatever is true goes to this path. So this is where we're going to make a condition to say like, hey, from this path, select a few points that are going to be the starting points of our branches. Okay, great. Let me set this as an output. I think this thing got twice as large because we're computing the origin two times. So at this point, I think I can just delete this. So now it went back, and that's good. And then here just reset everything together, which is again fine. Now I want to take the same node, just duplicated it and put it here. The duplicate, it's Control plus D. For visibility reasons, I will be maybe just decreasing this, and this one is going to be 1. So now when I'm going to put my condition here, we are going to see some brighter points appearing here. Those are going to be the starting points of our branches. So selector, and I will be using get float. So what I want to do is I want to, at equal distances and probably somewhere around here and here and here and here and here, I want to create a starting point for our bench. So in order to do so, I need to take our dollar, not dollar, but our ptnum0. Okay, variable, and I want to divide it by something, maybe 32. Okay, and then I want to take the floor out of this just to get rid of the floating points or decimal points. So, and then multiply this back by 32, and this, what I'm doing here, it's very similar to the quantized grayscale node. So multiply. Okay, and then set these things equal to each other. So this list with this list, when they are equal to each other, information is going to be passed on this branch itself. So if I plug this thing here, you can see those points appeared. Okay, great. It means that we have successfully created the seeds for our branches, so to speak. I mean, I think I have too many. I only want maybe this to be 64. So I have points here and here, and I might end up moving those points around. For now, leave it like this. Just want to have a look at here and see how I've done it here as well. So where is that? It's here. So I had a few conditions. Yeah, I added this 31 to it. Okay, so let me do it like this. Add and 31. So what this is doing is just offsetting the points further up. So instead of starting here, it's going to start later, and it's going to finish towards the end. I think this is what I done. Oh, I mean, it's actually going in the middle, right? Yeah, I also think I've done the same thing here. Yeah, so the leaves are actually starting in the middle, not at the, yeah, not here, at the furthest part, on the curved part of the sine wave. Okay, good. Now I need to go in here and do a few more things. I need to set one variable that I computed, but I also want to be able to access it. So go into the switch node, and we already have this part here. And I will be framing this and name it angle. Drag it a bit back and then angle. Great. But also I want to set it. Set. So ANG0 in short for angle 0 sequence, connect this. Okay, so now we have this information. Great. Now, in order to actually create the leaves themselves, I need to put another iterate node. So we can do from those points, we can start and add points close together in order to form the line for the leaves themselves. So iterate this and this. And then I think I can copy from this a few things. I will be copying this part. Go here, empty, go here. I want to change the name 1 and then do this to maybe 64 for now and only this. Oh, I mean, no, I think that was good. So I have this, but I also need to do one thing. So we computed origin 000, so now I need to take it and replace it with something. So get float to, as I mentioned before in previous examples, when you do this branching, you need to take the variable that you computed here, for example, position, take it and then set it to a different name. Otherwise, it's going to be overwritten here as well. So then I'm going to show you what happens if you don't do it. It's not going to do anything. I mean, it's not going to explode or anything. It's just not the effect that we wanted. So first I'm going to show you what we need to achieve, and then I'm going to show you what happens if you don't do this reassignment of the variable. So I'm going to take this origin 000 and set it to, I mean, I already have a sequence node that it's waiting for me. I just want to set this one to a new name. So origin 1, just plug the thing in here and then set this as an output. Great. Now go inside here and into origin 000, you should put origin 1. Go into our luminosity channel and compute our things. So first of all, do my T1 parameter. So get float, dollar number, set to ptnum1 sequence. Now get float ptnum1 divided by numpt1. Okay, division. Set T1 sequence, get float. We need origin 1. add to it something, set it. This is our update. Sequence. Finally, we want to output, I mean, we should output T1 as well. So get float T1 set as an output. Okay, so currently nothing happened yet, and the reason for nothing happening is because we haven't added anything here yet. So we need a and two, not sorry, a Cartesian that we always add here, and y. Okay, sorry about that. Actually, it needs to be a float 2, get float 2 origin 1. That's good. And also, I think this one needs to be deleted and replaced. Not this, this. Okay. And then get float 1 px. We need our magnitude or our length. And now we get it. We get the list. And definitely we'll be orienting them properly, but for now I just want to say like, hey, we used the correct variable here. I mean, we changed it from origin 000 to origin 1. Yeah. So if we do this instead origin 000 and origin 000, we get this effect, right? So it's kind of creating a line with that length in between this fragment here, and maybe I should put it like, should I put a 1 here? So it doesn't matter. So it's just creating this gap, and what's happening is that it's overwriting our origin 000 and creates this gap in between. So we don't want that, right? We want it to be like this and like this. Okay. Well, good. Now that we have this, we need to add the angle that we just computed. So get float, and it was ANG0. And if we plug it here, now we get it like this. Okay, so it's interesting already. Going here, maybe do a bit more instead of 36, maybe do 64. Okay, looking cool. And I want to curve those to make these leaves a bit curvy. So let me do this just now. When or where should we do it? Well, currently we have this angle, and this angle here aligns or make sure that our leaves align with the main spine of the plant. For example, if I go here and change the spine of the plant with this parameter, you're going to see that everything adapts, which it's interesting and cool. So we also want to curve them a bit. So how should we do it? Well, I'm going to use again the T1 parameter, and you can see the T1 parameter, we used it for luminosity. So it's like, hey, starts from 0 and ends with 1 here. If we add the T1 parameter, it's kind of going to curve our branch from very little to more and more at the end. So get float and T1. Okay, so it's adding it like this. Then how did I manage to do this part here? Because you can see if I add things now, it's rotating them in like one direction, but I wanted those not to be rotated up, but also be rotated in this direction. So how to solve for this? Well, if I put like a 1 minus here, it's doing this direction, which is not what I wanted, maybe negation. Yeah, so I want to blend between these two things. And I think I didn't do the same in our previous example. I'm going to test it, and then if it doesn't look close to what we have in our original example, I might be getting there as well. But also it's looking interesting already, right? So anyway, let me fix this. What I need to do is I need to count how many times how many times we created branches, and then use that information to make this to orient this like in this way and then in this way, things like that. So let me do it. I need to create a variable here that will allows me to keep track how many times we created branches. So set, I will be naming it val0. Okay, then I'm going here when we do the branching and say get the val0, and then we add something to it, which is 1, because we want to increase it by 1. And then if this thing here, if when we branch is true, then we want our value 0 to be increased by 1. Otherwise, we want it to be left alone and not change. Okay, so we do this and then set it to val0. Okay, and then sequence, chain everything together. Okay, that's already there, and now this. Perfect. So hopefully everything should work. Now I need to go here and then switch between these two. So linear interpolation. Okay, between this and this. And we want get float, we want val0. So this should be the val0 should be like, hey, 1, 2, 3, 4, 5, 6, 7, 8. But then if we take the mod 2 of it, then it should be something like 0, 1, 0, 1, 0, 1, 0, 1, something like that, or maybe 1, 0, 1, 0. But anyway, it's going to be an alternation between 0 and 1. And then if we plug this thing here, then this might be helping us with the switches. Okay, so looking good. Maybe I can switch like this. So if I select wires and then hit the X button, it's going to switch the input like this. Good. So I think this is already interesting for us, and I want to make those even more curvy. So I can multiply this, and if I multiply, then they go back to straight, because multiplying this curving parameter by 0, it's reducing it to nothing. But then maybe if we increase its strength to maybe 3, it's going to do this effect. Okay, and then maybe I want to even do it even more, maybe 4. Okay, but also you can see how it's kind of like a circle. We can also play with this and put a power and then float maybe 4. So you can see how now it's, instead of curving from the beginning, it's only curving at the end. Okay, so then if we play with this parameter, it's doing this or this. If I play with this parameter, it's doing this or this. Okay, maybe this should be left to a 3. And then I want to change this parameter, right? So I want to, instead of using a constant here, I want to use a variable. And I want to do it like this based on the length of the spine of the plant itself. So I can use the T0 parameter here, and also let me preview what's going on. Into luminosity, empty function, get float T0. Okay, it's like that. And then if I go in here, so I can use T0 to drive this information from here. So maybe, or blend between two values. So let's say that I want to blend between this, which is more curled, and maybe this, which is less curled, something like that. And I can blend between the parameter T0, not T1. So T0 is like this gradient going from dark to white along the spine itself. And it means that whenever we have T0 as a low value, it's going to be more of this or more of this, and vice versa. So lerp. Okay. So I think it's doing maybe let's switch things. I want to have more curled leaves at the top. So increase this parameter, and then less curled leaves at the bottom. Maybe like so. So I think this plant is different than what we had before, but maybe I'll leave it like this just to have a different example. I'll leave it like so. Okay, good. Now I want to do one other thing. I want to decrease the width of the plant stem. So maybe the thickness, make it like that. Go back to luminosity, reset it, and then just make it a bit darker. Okay, maybe 0.2, something like that. I also want to have a variable width or thickness for our leaves. So let me just do this. So our leaves are here. I'm going to delete this part briefly, and I will be going into the pattern size, empty function, get float. I think you already know that I will be using the T1 parameter, and then I will be using a linear interpolation because I want to blend between two values. So linear interpolation. And I want my initial width to be something like float 0.0005. I mean, maybe, I have no idea, maybe something like this. And then I want the thin part to be half of this, or maybe a quarter of this. So then I can just multiply this value by something like 0.25, which is going to say like, hey, whatever this value is, this other value is a quarter of this one. Okay, and then set this as an output. Well, I kind of can't yet. I need to have this as a vector float too. Now I can do this. Need to plug this thing back and see the results. So what's happening is that it's thicker here at the starting point and then it's thinner at the end. I want to have it in a different way. I want it to be thin at the beginning, have the maximum width in the middle, and then again thin at the end. So let's do that. Well, here where we do size, I'll do, instead of this T1 here, I just multiply this by pi. And then put a sign. So what this is going to do is going to, instead of creating a transition between 0 and 1, is going to create a transition that starts with 0 at the beginning, reaches 1 at the middle, and ends with 0 back at the end. So now if I put this here, we have it like so, which is weird. Why it seems to be, oh no, it's in reverse right now. So maybe I can just switch these together. Okay. And maybe it could be more, less. Okay. And then even this maybe 0.125. Okay. So those are my leaves. And at the end, I want to make a flower. Okay. So lastly, we have our leaves, and I want to make a flower at the end. So I need to do a switch here. And then in this thing, I want to put a condition, empty function, get flow. I want to select the very, very last point of this spine of the plant. So for this, I need to get the PT_num0 and also num_pt0. And I need to subtract 1 from this. Well, num_pt0 is currently, let me check, is 512. Okay, so this this PT_num0 starts with 0 and ends with 511, and then this is 512, so I need to subtract 1 from it, and this is going to be 511. And then if I do this like equal, now whenever this list here ends or reaches 511, then this is going to be true, and it's going to be transferred into this branch. So now I can go in here and say like, hey, we selected the tip of this thing and we're ready to create our flower because we have the starting point for it. Oh, good. So for the flower, we're going to do 2 nested loops. We have one nested loop, which is going to create for us the petal itself. And then the other loop is going to create the number of petals around the circle. Okay, so 2 nested loops like this. Okay, this and this and this. And we need to, maybe we can already copy something from this here. I think we can take this part and put it maybe here. And also maybe put it here. Okay, I'm just going to delete this thing, keep this one, num_pt1, it's good. This is the number of our petals, so definitely 64. I think it's too much, maybe put 17. And we will have a we will have a random number of petals for each plant itself. So this value here, which is a constant, it's going to replace with a variable. Also go inside here, get float $number. We need to make our t1 variable here as well. So set ptnum1 sequence get float divided by numpty1. So division set st1 sequence okay, set as an output, go into here. Oh, I already done that. Go in here into the empty, into luminosity, make our T2. And I think at this point I might be just faster to copy this part. Yep. Go in here and do it like this. This is 2. This should be 2. This should be 2. This should be T2. Okay, let me check if I name this. This should be numpty2. Okay, and we're updating origin 1. Perfect. So go here, go in here, get flow2 origin 1, add to it set origin 1. That's the update sequence set, not set yet, sequence. Again, here we are in the luminosity channel, so we will be outputting 1 for now. Okay, and then let's update things. So well, we need our Cartesian node, and then we need our magnitude, which is the 1 pix, get float 1 px, 1 pixel. And then it seems like it didn't do it. Why? Well, that was true, which is good. Then this is doing like 17 pixels, which is good. Just to make sure. think I think it's correct and it's still not showing it. So luminosity, it's 1, origin 1, maybe what do I have here? Origin 0, 0, 0. Okay. Maybe. And I'm trying to make sure that it's not a problem with the name of the variable. So I was expecting to see at least one long petal, but maybe Or maybe I haven't put this. No, it's 64. That should be good. So the petal should be like 64 long. Okay, and here it's, oh, now I understand what's happening. Yeah, of course. Sorry. Or at least I think I know what's going on. Well, yeah, this is the problem. So I just needed to update here as well. Sorry about that. That was it. Okay, so now it's doing this part. And then I want it to be aligned with the tip of my of the spine of my plant. So going here as well. Um, get float ang0. Okay, so now it's aligned to the tip. Then I need to add to it, and then I need to add in order to make it span the entire circle, I need to multiply my t, or which t I created here, t1. I need to multiply my t1 by 2 pi. T1 multiply by 2 pi. I mean, 2 pi, it's already there. And then it's creating the flower. Oh, great. I also want to show you how the T1 and T2 look. So the T1 looks like this. It's starting every single petal has its own brightness, and T2 looks like this. Like every single petal has its gradient from 0 to 1, which is like super useful that we have it. Okay. Now the flower itself, it's I think too big. So maybe we can just go here is where we control the length of the flower. So maybe put this to 32 instead. Yeah, I think this is a bit better. I also want to use the T1 for the luminosity or T2 for the luminosity. So maybe like this. I think this looks a bit more interesting as a flower. We could also add randomness, but I will add a bit of randomness to the length of the petals, but we can also add it to the luminosity itself. I think it's a bit more clear right now without the randomness for luminosity of the petals. But if we want, we can do it. I want to add a different condition so we can get rid of some of those leaves that intersect with our flowers. So when we do the leaves here, we should add another condition and say like end. And here we have our T0. So T0 is the length of our spine. And we can say like, hey, we want you to create leaves for us only when these conditions are met, but also when the length of our spine is lower than maybe 90% or something like that. So I can say, hey, the length of my spine is lower than 0.9 maybe. And I might need to change this value, but we can test it here and here. So then we should replace the entire thing. Okay, so the last leaf disappeared. Okay, so if I decrease this value, leaves are going to be disappearing. Okay, I leave it to 8.85%. And then, yeah, I want to add a bit of randomness to the length of the petals themselves. Well, Here we generate the length of the petal. So I can just, I think I can just say instead of 32, I can do maybe like float 32, add float 1, random 0, 0, 1 to minus 1, 1. I created a random number between -1 and 1. I want to multiply it maybe by 6. So this is either going to increase or decrease every petal with 6 points, and then do this, and then I want to cast this to an integer, so 2 integer. And now replace this constant 32 with this. So you can see now we're getting a variable number for the petals. Maybe 6 is too much, maybe 3. Kind of like it how it was distorted, but anyway, I leave it like that. Well, we have our flower, right? So at this point, this is our object. So object. Now we want to create a grid out of this. So for this, a new frame, move it, grid, this, this, and this, and do one and another one. Okay, so I'll be naming those again like inner and outer loops. This will be my I, this will be my J, going inside the first loop, empty function, integer, maybe 4, to float, set, this will be I, sequence, okay, that's 1. I want to copy the same thing, go here at the top, empty function, this will be J, set this as an output, go back in here and retrieve our variable, so get float dollar number, we need it, set, I will be naming this J++, sequence, here, here, and here. Great, great. I mean, it looked better before. Okay, also set this as a root. It executed them. I need to also get the dollar number from this one to here and name it I++. So get float dollar number, set I++, sequence, and then chain it, and then chain this. Okay, so now we have our original origin, so to speak, and we want to actually make a grid of multiple plants, right? So we need to change this thing. So I'm going to add to it because I want this to be like my main, or my original offset, but then I will be able to also work with my grid. So I want to add the vector float 2 to it. I mean float 2. I mean I need to make a, yeah, I need to compose a vector. Okay, and then get float, I need to get my I++, I need to get my J++. Okay, and then I need to also get my I and J. I, not this one, and also J. Okay, so J plus plus and I plus plus are the range of numbers, and we need to divide them by their counterparts. So divide I plus plus divided by I, it's going to give us a range between 0 and 1. Also divide like this. Okay, plug those things into the vector. Now we get a row. Now we also get a column, so we get the grid. Okay, I want to scale this. Scalar multiplication. Okay, and then let me go in here and maybe just have 3. Oh, this is okay. Maybe this one should be, well, it seems like I don't. Yeah, here I wanted to go. So maybe 3 or maybe 2. Okay, 2 for now. And we will be changing this later. Okay, so have it here. This is where I can move things around, so I can kind of center my grid of flowers. Then I want to use my Perlin noise to drive parameters of those plants, right? To link the parameters of those plants with the Perlin noise. So it's this, maybe just make it like that. Throw in an auto levels. And then just plug this thing in. So first of all, let me drive the number of petals. Let's start with the number of petals, and it can be driven by the Perlin noise. Okay, so go here. Where do I do my petals? Well, my petals are here, and the number of petals is here, right? So go inside, and I only need to do what I computed, and what I computed here is this. So it's origin 000. So I need this thing. This is where I generated the positions of my plants. So those are the starting points, like this. They are holding this variable. Okay. So I mean, just because I know we're updating this variable, let me rename this and say like, hey, definitely need the sequence, but what I wanted was a set. So I'll just name this grid because I know that these are the locations of my plants in the grid. Okay. So this doesn't get updated. This is just like really the basic point here. Okay. So it's sampling the Perlin noise correctly. Okay. So based on this value, I can just go in here and say like, hey, where we have petals, instead of having 17 petals, I want to do something else instead. So get float2 grid, and then sample the Perlin noise, and then linear interpolate between maybe float and another float. And maybe the maximum number of petals would be 17, but the minimum would be 5. And then plug those things here and then cast them to an integer. So to integer, and then replace that constant 17 with this variable. So now we have plants with different petals. Okay, that's one. I'm going to copy this thing And also go here where we can control the length of the petal. So this is the length of the petal. So maybe the maximum length of the petal will be 32, but the minimum length would be 12. And then just do this. So you can see not only we have less petals, but also they are like less longer. Let's do the same thing with the leaves. So the length of the leaves, it's here. And we have 64 currently, but maybe we can do between 24 and 64. And to integer and just replace this. So maybe even, maybe let's do a bit more here, like 80, something like this. I can also decrease the thickness of the leaves based on the same parameter coming from the Berlin noise. So I'll be copying this, go into the size and have it like this. So what we want to do, we want to use the current thing that we have and then this and multiply it maybe by half. So this is the current width that we have. So it's starting thin, going maximum width, and it's going back again thin. This is here, but then we can take this and multiply it by a lower value. Let's 0.5, for example. And if we preview this, you can see like how everything got thinner. And now we can blend between those two. So that was the original width, this is the new one, and then this is the latest. Okay. And I think it maybe needs to be switched. Maybe like 0.1 just to make sure that I see what's going on. Oh, this is like yeah, this is the entire plant. So the ones that are longer should be thicker. Yeah, this is correct. Definitely exaggerated just to see them, but it's correct. Maybe do here a bit more, like 1. Okay, well, definitely not the best leaves in the world. I can tweak their length a bit more here. So the minimum seems to be 24, maybe it's a bit too little, maybe 32. Okay, didn't want that. Okay. Yeah, I think this is better. So we can also take this and copy it and affect the length of the entire plant. So the length of the entire plant is here, it's 512, and we can change it between maybe 512 and maybe, I don't know, maybe 256. Put this to an integer and then replace this value. Okay, so we have different lengths for the plant. Okay, also we need to do this thing to the waviness of the plant. So it should be affected by the early noise as well. So the waviness of the plant is here in this parameter. That's the strength, but here it's like how many of those waves we have. So I want to play with this parameter. So maybe and between 4 and 1. Okay. I think this didn't work. Maybe let's put like 0. And I think needs to be in reverse. Yeah, this is okay. I also think some plants should be longer, so I think we should change the range here. So maybe make this one lower and this one higher. And this one even lower, maybe 1 to 8. Okay. I am not satisfied. I don't think I get like enough variation, and there seem to be like they're all the same. So maybe I can also, yeah, I know. I can also play with this as well. So here is how many ways do I have. But here is like the strength. So I can do another linear interpolation here between these values. Instead of 4, I can just do this and see what's happening. Okay. Maybe add a bit more plants. So at this point, I'm just adjusting things. Maybe just decrease the plants. Yeah, I think in this case seems to be more readable defect. Definitely you can, at this point in time, you have plenty of parameters to change and to adjust and to make it look more interesting. Just don't want to spend more time than needed on this part. So also I think, did I scale this? Yeah, I scaled the grid, so I can rescale back and reposition it like so. Okay. So now if I change this, I should be seeing differences happening to my plants. So changing the disorder here, yeah, you can see how it's affecting the plants. Which I think it's interesting. Also, I want to say that maybe maybe we can try this as well. I think in my other example, I have a slightly different setup, which is not good or bad or wrong or anything like that. But remember that I also created this variable here, grid. Maybe I can just put this here. Okay, so now it doesn't change anything. But instead of using the grid, if I use origin 0, 0, 0, I think I'll get a slightly different result. Okay. The last thing that I want to add is just I want to add a slight random orientation for each plant. So where do I have my orientation for the plant? Well, it was here. So this is the how my plants are oriented. Well, I can just I can put a random variable here. So for example, this is, I want every time a plant is created in my grid, I want to generate a random value. Where should I generate this, or where should I create this variable? Well, this is executing the grid. So below this, in this node, I need to create that random variable. Okay. So float and 1 and random and 0, 0, 1 to minus 1, 1, set. This is from random angle. And then put this thing here, okay? And then now back here, when we actually did the rotation, I want to add, and then get float and then rank. So now everything should go absolutely nuts, but then we multiply this by a number, not the minimum, sorry. It's looking interesting, but not that. So multiply. Okay, something like that. Okay, so there you have it. I think the last one is a really interesting result, and also not only interesting but also powerful. Definitely please play with it and make it a bit more interesting and beautiful. I think I had a slightly more beautiful version here. I'm not entirely sure, depending on what you want or what you like. Like in the end, I don't even pretend it's to be beautiful, but more interesting rather than beautiful and useful. I'm pretty sure we're going to come up with something much, much cooler than what I did. But try to do these examples once or twice or multiple times, and repetition is going to be key. I know things might be confusing and you kind of don't understand why do I do things. I will be making more tutorials, and then by repetition, you're probably going to start and see or understand what needs to be done and when needs to be done. Okay. Thank you so much for your patience. I hope this tutorial is going to be useful for you. Also, if you feel like this is useful, please share it with your friends or maybe with your peers. I think they might find it interesting. Thank you.